Here we'll look at determining a molecular formula. You'll have data that might look similar to this. Calculate the molecular formula of a compound whose molar mass is 60 grams per mole and has an empirical formula of CH4N. Okay, so we are given the little simplified empirical formula, and the key piece of data now that we're also given is the true molar mass of the compound. We would have to be given that data. And so here's how we can go from an empirical formula to a molecular formula. Step 1 is to calculate the mass of the little empirical formula. Super easy. You can just do this right on your calculator. If the little empirical formula was CH4N, you'll just add carbon 4, hydrogen 1, nitrogen, and get the little empirical formula's mass, the EFM, empirical formula mass. Okay, well now I know that the real molecular formula is going to be some multiple of 1, 4, 1. So the original formula had a ratio of 1, 4, 1. Eventually I'm going to multiply that by 2 or 3 or 4. Is it going to be double, triple? I don't know. We'll get that multiplier by comparing the true molar mass of the compound, which has to be given to us. We're going to compare that to the empirical mass. So the true molar mass is going to be given to us. That was 60. Well, the mass of the little empirical formula was 30. And so all you'll have to do is divide. Take the larger mass. The true molecular mass is always going to be larger than the little empirical mass. You'll divide them, and you should get a whole number. Then that just becomes your multiplier. We're going to multiply the ratios by 2. So instead of the little empirical formula having a ratio of 1, 4, 1, now the true formula, the molecular formula, should be 2, 8, 2. We're just going to double the ratio. And does it make sense? If you're ever unsure, you can just check the mass of this guy. If you add this up on your periodic table, 2 carbons plus 8 hydrogen plus 2 times nitrogen, what do you know? It's really right around that 60 grams. Then check. I know I did it right. All right, let's try a few. So here's 2 good examples. Find the molecular formula of ethylene glycol used in antifreeze. Notice that they have to give us the true molar mass of the compound. And they're telling us the empirical formula. So first we have to find the mass of the empirical formula. So I'm going to take my carbon. That is about 12.01. I'm going to multiply by 1. My hydrogen is about 1.01. I'm going to multiply her by 3. And I've got 1 oxygen. 15.999. Now, realistically, at this point in the game, I trust that you can just do that in your calculator. And that would be totally acceptable on a summative. I mean, earlier, if the question is just asking you to show work for the molar mass, well, then I'm going to show work for the molar mass. But now, once I get beyond that, it's about the empirical and molecular formula. You can just add that mass in your calculator. Oh, let's see here. 12.01 plus 3.03 plus 15.999 gives me a mass of about 31.039. Perfect. And now they have to give you that true molar mass of the compound. And all I have to do is compare them. And hopefully I get a whole number ratio. So this isn't an accident that the real molar mass was 62. And my little empirical is right around 31, right? 31.039. Now, obviously, when you divide them, it might not be perfect, but we are darn close to a whole number ratio. Ooh. Then all I have to do is double my little empirical formula. So I'm going to take 2 times the CH3O, and I'll get a ratio of C2H6O2. Done. And if I wanted to confirm it, if I wasn't sure, then I can just add the carbon, hydrogen, oxygen, and I should get a mass of 62 grams. Well, this isn't so bad, right? It's almost kind of fun. These calculations are great because once you know how to solve them, all I can do is just give you different numbers or different elements, but it's the same process. So for example, watch how fast this could be. What is the molecular formula of a compound with an empirical formula of CClN? A 1-to-1 ratio between carbon, chlorine, and nitrogen. All right, well, let's add them up. The CClN has a molar mass of, add them right off your periodic table, 1 carbon, 1 chlorine, and 1 nitrogen. Awesome. I'm right around 61.47 grams per mole. Okay, now I'm going to do a little comparison. I'm going to take my larger molecular mass, the 184.5, and divide by my little empirical mass, 61.47. And I hope for a whole number, 184.5 by 61.47. Whoopsies, I should probably plug that in my calculator, right? 0.5, there we go, by 61.47. Perfect. 3. These really should come out to a whole number multiplier. So now all I have to do is multiply my little empirical formula, CClN, by 3, so that my new ratio is C3Cl3N3. And if I wanted to confirm that I did it right, if I add the mass of my new molecular formula, I should get the 184.5.